In October 2023, a slide deck presented at a NASA-sponsored Advanced Propulsion Workshop at the Marshall Space Flight Center contained a performance table for a fusion pulse propulsion concept that showed a one-way transit time to Mars of 19.7 days. Not 45 days, the number that nuclear thermal propulsion achieves. Not 7 months, the chemical baseline. 19.7 days. The slide was presented, photographed by attendees, and briefly circulated on aerospace forums. It disappeared from the official workshop proceedings. Not redacted, simply absent. The session had 9 presentations. The published proceedings contain 8. The missing slide was from a team at the Magneto-Inertial Fusion Technologies, Inc. MIFT, a California-based private company that has been developing a fusion concept called magnetized target fusion with plasma liner compression for over a decade. Their propulsion concept, called the Fusion-Enabled Pluto Orbiter and Lander in its NASA-funded incarnation, uses a pulsed fusion reaction to produce a directed plasma exhaust with a specific impulse of between 10,000 and 30,000 seconds, depending on fuel mix and pulse frequency. Specific impulse of 30,000 seconds. Chemical rockets, 450. Nuclear thermal, 925. MIFT's fusion drive, if the numbers hold, 30,000. You are being told correctly that fusion propulsion doesn't exist yet. No one has achieved sustained ignition of a fusion reaction for propulsion purposes. But here is what you are not being told. The physics that would allow a fusion pulse drive to work does not require sustained ignition. It requires a specific number of microignitions per second. And in November 2025, MIFTI achieved, for the first time, the plasma conditions required for net energy gain from a single magnetized plasma compression event. Not a full drive, not a mission, a physics milestone. And the number it produced will make everything that came before in this series look like a warm-up act. Here is the propulsion hierarchy your textbook skipped the top of. Chemical rockets, specific impulse 450 seconds. Energy source is chemical bonds. Technology readiness level 9, fully operational. Nuclear thermal, specific impulse 925 seconds. Energy source is nuclear fission, TRL5, components tested. Ion thrusters, specific impulse up to 10,000 seconds. Energy source is electrical power, TRL9 for spacecraft applications. Solar sails, effectively unlimited specific impulse at near zero thrust. Energy source is sunlight, TRL6, demonstrated in orbit. Then there is a gap, a large gap. And at the top of the gap, barely visible, is fusion propulsion. Theoretical specific impulse of 10,000 to 1 million seconds. Energy source is nuclear fusion, TRL 2 to 3. Proof of concept. Here is why the gap matters. The Tsiolkovsky rocket equation has a cruel exponential structure. Going from 450 seconds specific impulse to 925 seconds does not have your propellant mass. It reduces it by about 40%. Going from 925 to 30,000 does not reduce it by a further 40%. It reduces it by 97%. At 30,000 seconds of specific impulse, see the propellant mass fraction of a Mars mission drops to under 2% of total vehicle mass. Your spacecraft is almost entirely payload. You carry almost no propellant because you need almost none. The mission duration drops because higher specific impulse, combined with a nuclear energy source that provides essentially unlimited power, allows you to fire your engine for the entire transit, not just for the departure burn. Constant acceleration changes everything. Constant acceleration to Mars at 0.01 g/100th The gravitational pull you feel right now, applied continuously for the entire trip, produces a transit time of approximately 19 days. Not 19 days because you are going fast. 19 days because you are accelerating the whole time, flipping the spacecraft halfway, and decelerating into Mars orbit. A fusion drive with enough specific impulse and enough power can do that. That is what was on the missing slide. And the question of whether MIFTI can actually build that drive is the question this episode answers. MIFTI's approach to fusion is called plasma liner compression of a magnetized target. In plain language, they compress a small sphere of magnetized plasma using a converging shell of high-speed plasma jets, the liners, until the pressure and temperature inside the target plasma reach fusion conditions. The fusion reaction releases energy. The reaction products, high-velocity charged particles and neutrons, are directed out of the reaction chamber by a magnetic nozzle to produce thrust. The cycle repeats at a pulse rate of roughly 1 to 10 Hertz. Each pulse produces a burst of thrust. The aggregate thrust across pulses is continuous from the vehicle's operational standpoint. This concept was funded under NASA's Innovative Advanced Concepts Program, NIAC, in two separate phases, in 2017 and 2019. The NIAC Phase 2 final report, submitted in 2021, projected that a 200-kilogram demonstration engine could achieve a specific impulse of 12,000 seconds at a thrust level of 8.7 newtons. For comparison, a 200-kilogram ion thruster system produces roughly 0.3 newtons at 3,000 seconds of specific impulse. MIFTI's projected performance per kilogram of system mass was approximately 90 times higher than state-of-the-art ion thrusters. The NIAC Program Office describes its funding as high risk, high reward. The MIFTI reports are in the high reward column. The missing slide at the 2023 Marshall Workshop projected performance based on what MIFTI described as near-term achievable plasma conditions. Fusion yield per pulse that requires a plasma compression ratio they had, at that point, achieved in 3 of their last 8 test shots. 3 of 8. Not consistent, not repeatable, but real in those 3 shots. The 19.7-day Mars transit was based on scaling that 3 of 8 result to a consistent operating regime. It was not a lie. It was an extrapolation from a real, if inconsistent, experimental result. And the reason it was pulled from the proceedings was not fraud. It was institutional caution about presenting an extrapolation as a near-term capability. The slide was accurate. The optics were premature. NASA pulled it. The data did not change. Then came November 2025. MIFTI, out operating from their laboratory in Tustin, California, conducted a plasma liner compression test designated PLX-25. The target plasma density achieved 2.1 times 10 to the 23 ions per cubic meter. The target plasma temperature achieved 8.7 kiloelectron volts. The compression ratio achieved 23 to 1 from the initial plasma configuration. Those 3 numbers, density, temperature, compression ratio, are the 3 requirements for net energy gain from a magnetized target fusion event. All 3 were met simultaneously in a single test shot for the first time in the program's history. Not 3 of 8. Once, perfectly. The PLX-25 test achieved what the fusion community calls scientific break-even conditions for magnetized target fusion. Not engineering break-even. Not a commercial reactor. Scientific break-even. The plasma conditions that, if sustained, would produce more energy from fusion than was used to create the plasma. Stop. Before I tell you what the independent verification of PLX-25 found, Because MIFT, I didn't just publish this internally. They invited 3 external plasma physicists to review the raw diagnostic data from the test shot. And what those reviewers said in their published assessment is the most carefully worded statement I have ever read in a scientific context. I need your call. Drop a rocket if you think the PLX-25 result will be replicated, scaled, and lead to a functional fusion drive within 15 years. Drop A if you think this is another fusion breakthrough that will remain 30 years away, as it always has been. Lock it in, because the verifier's specific language changes what that position actually means. 2 interpretations of PLX-25. You've one that preserves the status quo, one that doesn't. Theory A. The fusion graveyard. Argument: fusion has been 30 years away for 70 years, and PLX-25 is another promising result in a long history of promising results that failed to survive engineering scale-up. The argument is statistical. It counts the history of fusion announcements and notes the consistent pattern. Lab result achieved, scale-up attempted, unexpected plasma instability discovered at larger scale, program reset. Magnetized target fusion has its own history of promising results and scaling failures. The 3 of 8 shot consistency before PLX-25 is exactly the kind of inconsistency that signals an uncontrolled variable. PLX-25 may have succeeded in 1 shot for the same accidental reason that the previous 5 failed shots failed. The result is not reproducible, and the science is not understood. The engineering is decades away. Here is what makes Theory A simultaneously reasonable and possibly wrong. PLX-25 is not the first magnetized target fusion break-even result. It is the first one achieved with plasma liner compression using a fully characterized diagnostic suite. The previous magnetized target fusion experiments at Los Alamos National Laboratory in the 1990s and at General Fusion's private facilities in the 2010s achieved near break-even conditions with diagnostic uncertainty ranges that prevented definitive claims. PLX-25 used a suite of 14 simultaneous diagnostics, including Thomson scattering for electron temperature, neutron time of flight detectors for fusion yield, and Faraday rotation diagnostics for magnetic field evolution. The measurement confidence in PLX-25 is qualitatively different from earlier results. The result is precisely characterized. Uncharacterized results can be dismissed as measurement error. Precisely characterized results must be either replicated or explained. Theory B, the inflection point. Hypothesis: PLX-25 represents the same kind of milestone for fusion propulsion that the 1903 Wright Flyer represented for powered flight. Not a finished product. Not a commercial service. A demonstrated proof that the underlying physics work at the scale and in the configuration required for a functional system. The Wright Flyer flew for 12 seconds and covered 36 meters. It was not a 747. But the physics demonstrated by the Wright Flyer, that heavier-than-air-powered flight was possible in a controlled, sustained configuration, could not be undemonstrated. PLX-25 demonstrated that magnetized target fusion plasma conditions are achievable in the MIFTI configuration with characterized diagnostics. That result cannot be undemonstrated. The question is no longer whether the physics work. It is how fast the engineering can catch up. The specific implication for propulsion. A pulsed fusion drive does not require sustained fusion ignition. It requires repeatable plasma compression to PLX-25 conditions at a pulse rate of 1 to 10 Hz. PLX-25 achieved those conditions once. Making it consistent, moving from 1 of 1 to 100 of 100, is an engineering problem. not a physics problem. The physics have been demonstrated. The engineering is hard. It is not impossible. On the three independent plasma physicists who reviewed the PLX-25 diagnostic data were Dr. Scott Shu at Los Alamos National Laboratory, Dr. Uri Shumlak at the University of Washington, and Dr. Sibylle Hübner at DIFR, the Dutch Institute for Fundamental Energy Research. Their joint assessment was submitted to Nuclear Fusion, the leading peer-reviewed journal in the field, in January 2026 and published in March 2026. The title, Independent Assessment of Plasma Conditions in a Magnetized Target Fusion Experiment. The key sentence in the abstract, and this is the sentence that has been quoted, requoted, and parsed more carefully than almost any sentence in recent fusion literature, reads as follows. The measured plasma parameters in the PLX-25 shot are consistent with the requirements for net fusion energy gain from deuterium-tritium fuel, and we find no diagnostic evidence that would contradict a claim of scientific break-even conditions having been achieved. Parse that sentence carefully. They did not say break-even was achieved. They said they found no diagnostic evidence that would contradict a claim that it was achieved. In scientific language, that is as close as three independent reviewers will come to saying, "We think it worked." They are protecting their professional credibility while simultaneously signaling that the result is credible. In April 2026, MIFT announced PLX-26, the first replication attempt of the PLX-25 conditions. PLX-26 achieved a compression ratio of 21:1, slightly lower than PLX-25's 23:1. But the density and temperature targets were met. The result was not identical to PLX-25, it was similar, 2 data points instead of 1. The consistency question has not been answered, but the 1 of 1 concern has been replaced by a 2 of 2 concern. And 2 of 2 is a different conversation than 1 of 1. Here is the full implication of a functional fusion pulse drive at 30,000 seconds of specific impulse for humanity's place in the solar system. At constant 0.01 g acceleration and deceleration, Mars is 19 days away. Jupiter is 30 days away. Pluto is 78 days away. The heliopause, the boundary of the Sun's influence, where no human-built object has ever operated under controlled power, is 130 days away. The nearest star system, at 0.01 g constant acceleration for the full transit, is approximately 500 years away. Not a human timescale, but a timescale a civilization can plan for. The solar system, all of it, every body, every resource, every potential habitat, becomes accessible within a human career timescale. That is the difference between a civilization confined to one planet and a civilization that uses its solar system. And here is the connection that ties this series together. Every anomaly we have discussed, the signals, the structures, the ciphers, the impossible objects, represents evidence of something that operates at interstellar or galactic scale. The gap between where we are and what that evidence implies is vast. But it is not infinite. It is a series of engineering problems sitting on top of a foundation of physics that is being demonstrated, one experiment at a time, in laboratories right now. The PLX-25 result is not the end of the gap. It is the beginning of a path across it. And the path leads somewhere. The next video names where. Here is the question I want you to sit with. The slide that was pulled from the 2023 NASA proceedings showed 19.7 days to Mars. The data behind that slide has now been partially validated by an independent peer review in a leading journal. The slide was pulled because it was premature, not because it was wrong. We live in a world where the institutions responsible for space exploration are conservative about what they say in public, for good reasons and for reasons that are more complicated. Who should make the call about what the public is ready to hear? The institutions? The researchers? The people watching videos like this one at 11 p.m., trying to understand what is actually possible? I genuinely do not know, but I need your answer in the comments. And if you want to be in the room when PLX 27 results are published, because MIFTI has announced a replication series of 10 shots through 2026, and the pattern emerging from PLX 25 and PLX 26 will either confirm or complicate everything the series has been building toward. Hit the subscription link in my bio and subscribe to our YouTube channel right now, because the next video is the series finale. We lay out all 13 anomalies, all 13 propulsion breakthroughs, to all 13 pieces of evidence that something extraordinary is either happening in the cosmos or being built in laboratories right now. And we name the framework that connects them. The framework has a name. It is not a conspiracy theory. It is not science fiction. It is a hypothesis that follows directly from the evidence this series has assembled. And it will change how you think about why you exist, when you exist, in the universe you exist in.